Hockey incorporates physics in many ways. You can see it most in shooting, skating, and passing, along with the physical aspect of the sport. The player is balanced. Gravity is centered and weight is distributed equally on both legs. There's no potential or kinetic energy. As the shooter winds up, their weight is on the back leg and stick is raised above their hip, building up the potential energy. The potential energy from the back leg transfers to the front, turning potential energy into kinetic and putting force on the puck to take the shot. The force of this motion, along with your arms and movement of the torso towards the net, is what gives your shot power. You can calculate the kinetic energy of a puck with the formula kinetic energy equals 1/2 mass times velocity squared. The mass of a puck is 6 ounces, which is about 170 grams. You can find the velocity of the puck by finding distance over time. The puck travels with two-dimensional motion. Force from our stick moves the puck forward as gravity pulls down. Your stick hits the ice before hitting the puck, so it flexes and can shoot the puck with more potential energy. Although during a game, players do not calculate, trigonometry is very useful for aim. Knowing the height of the net and your distance from the net, you can figure out the perfect angle of elevation which you should shoot the puck by using tangent. Often during a game you have to make an indirect pass off the boards. Tangent can also be used to find the correct angle off the boards at which you will hit your target's stick. The angle of incidence at which the puck hits the boards will be the same angle of reflection that the puck bounces off the boards at. The amount of power will be the same, since the puck hitting the boards is an elastic collision. When there is elastic collision, the object bounces off and keeps the same speed. Passing is like moving the puck on the hypotenuse of a right triangle. Instead of skating vertically, stopping and passing horizontally, you pass diagonally, which shortens the distance and allows the player to skate into your pass. An example of an inelastic collision is when the puck hits the goalie or a player hits another player. The object does not come out of the hit with the same amount of speed and energy like it does in an elastic collision. The force of gravity on a free-falling object is force of gravity equals mass times 10 newtons per kilogram. By using the formula, you can figure out the free fall of a puck during a face-off. The mass of a puck is 0.17 kilograms. The puck falls with 1.7 newtons of force. To figure out how long it will take the puck to drop, you make a distance, time, and acceleration table. Say for example the ref is dropping the puck from 5 meters. We want to figure out how long it will take for the puck to drop to the ice by filling out the table. Acceleration is always 10, because that is how hard gravity pulls on each object. We can also fill in the time in seconds. We want to figure out the velocity because we know the object accelerates at 10 meters per second, so for each second the velocity increases by 10. To figure out the distance, we have to find the average velocity first. We do this by finding the average between the first two velocities. Now we can fill in that column. To find the distance, we add the average velocities together. We can see that it takes 1 second for the puck to drop. We are told to move our stick on a face-off when we see the ref drop the puck, not when it hits the ice, or else we will be too late and miss the face-off. A clean sheet of ice at the beginning of the game applies very little friction on the puck because it is so smooth. If the ice is still wet at the start of the game, then the puck gets stuck in the water. As the game goes on, snow will build up on the top of the ice and make the puck move slower. Most teams will resurface the ice in between periods to start with a frictionless surface every new period. When you take a shot, you want to decrease the air friction on the puck so that it goes fast and as straight as possible. You do this by putting a spin on the puck, moving it from the heel of your blade to the toe during a shot. Hockey is not only a fast and rewarding physical sport, but it is played with math and physics.